Comparing that to the UDP header, you see that the UDP header is a much, much simpler entity here. It's, as simple as we can possibly make it. It's a source port, a destination port, how long is it, and a basic checksum of the header, and away we go. No additional code bit fields or sequence acknowledgement bits, and no options. It's, what's the source application, what's the destination application, how long is it, and go. So the UDP header, again, is designed for speed so that we can transport the data as quickly as possible across the network. To overview the application layer of the TCP/IP header, let's take a look at some of the common protocols we'd use inside the application portion of this stack. So to transport files across our network, we might use something like FTP or TFTP. The trivial portion of the trivial file transfer protocol is because it's using UDP as opposed to TCP, like the file transfer protocol. In those particular cases, don't think that TFTP is completely unreliable, though. TFTP, although built for speed, does block number all of the things it transfers. So if it loses a block in transit, it can re-request it at the application layer. It doesn't rely upon the layer 4 TCP protocol to do its reliability. Things like the hypertext transfer protocol, HTTP, is used commonly as port 80 for our web transfer of data through the network from browser to web server. We have email applications, simple mail transport protocol, POP, mail, and so on. Remote login. Now, I didn't even put Telnet on the list because I don't want you guys to use Telnet anymore. Really, we need to be using SSH, which stands for Secure Shell. It's an encrypted session that we can use to connect to our devices, in particular, router and switch login at this point. And the advantage of SSH is that it securely connects to and from those devices so that anybody who was able to watch those communications wouldn't be able to see the data. Management protocol, SNMP, Simple Network Management Protocol, and we've already mentioned the name management protocol, domain name system. So these are common applications used inside of the TCP/IP stack. Again, application layer allowing us to do inter-host communication and sending data from one device to another device across a network. So I wanted to take this chance to reiterate something I mentioned before, and just to make sure everybody's clear on that. To map between a layer 3 protocol and a layer 4 protocol, there is a field inside of the IP header, coincidentally called protocol. Now that protocol is how we know what's happening from a layer 3 perspective, what's going on at layer 4. So the number, the value given inside the protocol field, identifies what's going on at layer 4. So is it a UDP header or a TCP header or some other form of header? It's a value between 0 and 255. Most of those have been defined. The common ones, again, ICND, TCP, and UDP as far as the protocol field. But there's others that you might run into. Things like OSPF or EIGRP or GRE, which is generic routing encapsulation, so we could send, say, IPX traffic over an IP network. We stick an extra IP header on top of another layer 3 protocol header. Those type of things are defined in the protocol field and allows us to map from the layer 3 IP header to the layer 4 TCP or UDP header, usually. In mapping between layer 4 to the application layer, we have predefined values inside the port field that are well-known port numbers. I've already mentioned a few, but you should have these memorized. Things like port 20 and 21 for FTP. HTTP uses port 80, also 443 for secure HTTP. SSH uses port 22. I mentioned DNS is both defined for port 53, TCP and UDP for transport of data via server-to-server transport, TCP, or from host to DNS server using UDP 53. TFTP is port number 69, and SNMP is port 161. But there's a lot of different ones in here. You can certainly go out to a couple different RFCs out there to define all of the different registered port numbers. And that's one of the few living documents. The RFC in question, I remember RFC 1700. It did get obsoleted a few years ago, and I never can remember that number. 1700 always sticks with me because I know it's there. But the live nature of that document is very different from other RFCs. Most RFCs are built, they're stagnant, and once changed, they have to be obsoleted by another RFC. In the case of the port mapping RFCs, we continually update and change those RFCs and and are able to play with those documents and change them on a day-to-day, month-to-month basis as the registered port numbers might change. So you can certainly go out to the RFCs and look up the registered, well-known port numbers that are predefined by the IETF.